guys, welcome to Expertisor Academy. Today we are into the Civil 3D playlist, and then we're gonna see how to draw some alignments. So the alignments are horizontal control within Civil 3D. So if you have used other civil design softwares, sometimes when you try to create a corridor or a pipe, it generally has one 3D control line. It will control both from the plan view, from the horizontal plane, how it actually moves, and then from the side view, or you can call it as the z-axis, where it controls the levels. So it's pretty much like a 3D polyline, and then your pipe or road travels through that. So that is what most of the other software does. Whereas with Civil 3D, we got two control lines. One is your alignment, another one is your profiles. So the alignment controls how the pipe or road travels in a horizontal plane, and then the profiles control the vertical plane. So they combine together, controls the object. Okay. First, let's see how to create an alignment. So to do that, we can do it in a few different ways. One is in the tool space. This is your alignment, and so this is all the type of alignment, center line, offsets, and things like that. And so you can create here, and you can create folders as well on the newer version, that is 2018 onwards. And make sure your 2018 is updated, and you can create your alignment within these folders. Okay, so to create an alignment, so what you do is you go to your home tab, and under that you see your design, create design panel, and in that you got alignment. Click on the drop down, and you got a whole bunch of tools here. So I'm going to go through only few of them on this tutorial. So first one is alignment creation tools. So this one, click on this one, and then it gives you the box where you just fill in the name of the alignment, and let's say this is for M1 road center line alignment. And you can also specify the kilometer range. Let's say if this is between kilometer range 18 to 122, you can specify the range here or here. So this will be, let's say, M1 road project kilometer range, let's say 18 to 122 kilometers. It's just as a reference, it doesn't have to be too accurate. It just shares that when you look at the alignment list of alignments from the tool space or in a report, you can get to see that, okay, it's not just alignment 1 2 3 4 5. Okay, what does it mean? So now we know we have making it a bit more meaningful. And you can add an alignment into a site. Sites are more like buckets. So what will happen here is, whenever you create a site, you can add some site objects. Site objects or alignments, your feature lines, your grading group, and parcels. So these four are site objects. So these objects into a bucket. So anytime, so let's say so let me get this drawn so you can see it. So now, so what happens is every time you got a bucket, let's say this is bucket 1, and then this is bucket 2, and then you can put some alignment inside, alignment, feature line, grading group, parcel. The same way you can put another alignment, and then feature line, and then grading group, and then parcel. So now this is 1 and this is 1. So, and then there are some objects you can keep it outside. Let's say this is alignment 3. And so not all objects are having this option to choose as non-site. That means it will be outside of any of those sites. So now this is site 1 and this is site 2. So now the thing is, the object which is outside of a site can interact with all the objects within all the sites, and then objects without any sites as well. And objects within sites, they cannot see object in the other sites. So that way, if you're drawing a road, and then let's say let's make it good. Let's say we're drawing a road, and then let's say if there is going to be an option for the same road to go in this way, this is option 1 and option 2. If you put them into site 1 and site 2, so these alignments will not talk to each other. So that means they can lie on top of each other without having them interacting with them, so that it doesn't change the design because it has got a batters here, and so that this design will not affect. So they can pretty much lie on top of each other without even seeing each other. So this is called a site. So now, so we're going to choose it as none for now. So we will do sites a little later, and then so we'll choose an alignment style. So there is plenty of styles here. So we're going to choose ANZ design. So we will have a separate chapter on customizing the alignment styles. This will take some more time. And then the alignment label style. So we got for pipes, we got for rails, highways, and different styles. So you can choose whichever you like. And then once you're happy, we can click on OK. So one last thing is the design criteria. So this is like you can specify, imagine this is you using it for a road. You can specify what's the design speed targeted for this entire alignment. Remember, the alignment will have curves, so the curves will have speeds which is lower than the straights. So for this one, you can set as a sort of like a minimum speed that you can use it through the alignment, and then you can go into each of those curves and you can set the different speed. We will see that as well. And then we can also assign a design criteria file. So this is something I worked on the ANZ country kit for Australia a few years ago, probably I think the 2013-12 versions, and in that one I have done a lot of these calculations. So what it does is for a minimum radius table right now, this is using 2010 Road standards, and this is same with any of your other countries as well, guys. So it's not going to be too much different. So if you're using UK or India or China, whichever the country you're using, so they will have their own standards. So it's just the standards. And then the super elevation is minimum is 5% super, and then the transition length is one lane, so it's not a multi-lane, it's a single lane. And then the attainment method is Road standard percentage visit. So this one I'll explain to you once I create the alignment as well. So these files, you can find it when you click on this ellipsis button. You can get to see all these files here. You can even open this on a notepad, and then you can see the XML code and you can edit it. If you look at it, what it does is it does the standard super elevation calculations. It's a formula, and then it uses, let's say if the minimum slope is 5%, if the radius, so what will be the minimum radius? So we're saying that when the user is traveling at 40 kilometers an hour, the radius is 36. When the user is traveling at 60 kilometers an hour, the radius is 98. So the same way, if you go to, let's say, higher super, so when the minimum super is 10%, that means, the road on the outer edges is actually sloping quite higher. So let's say, let's do this. So now let's say we got this road curving, and then if you look at this, so this road on this side, it's like that. So there is a little raise. So this is your super elevations. So now this is like, first is like we got a 5% super elevation, and then 7% and 10% you can have bigger super elevations. Most cases in the urban roads, people tend to avoid bigger super elevations because there will be a lot more pedestrians and push bikers, and a lot of these people who will not be traveling at a minimum speed that they need to travel at the outer edge of the super, so which might create some issues. So now going back to the calculation, so now let's say if you go to a higher super, then if you're traveling at 40 kilometers an hour, now the radius can be shorter. So now if you compare this one to this one, if you can see that the radius has to be bigger, or else what happens is when the vehicle traveling at this speed, let's say 40 kilometers an hour, and so they will stay on the track. If they go over 40 kilometers an hour, then the radius has to be bigger. So if you use the same radius and people are traveling at much higher speed, they will not be able to stay on track. They will go off the road. Okay, and then which will cause accidents. Okay, so this table will give you guidelines. There is multiple different types of tables as well. You can choose it. Based on that, it will apply the criteria. And then you can use a design checks as well. So just like along the tangent lines, it just draws some lines. So not to worry, so we just leave this one as such. And then the starting station, so now let's say if this alignment is a continuation from a previous alignment, you can use a station from the previous alignment, the ending station from the previous alignment. Okay, click OK, and then you get the flyer toolbar. Remember I said about the flyer toolbar, so make sure whenever you use flyer toolbar, once you're done with the operations, make sure that you close it. Okay, so it looks like there is some glitch up here in the flyer toolbar. Okay. All right, that's all right. So now what we're going to do is we're going to go from left to right. So the first one is the drop down that says you're going to create an alignment tangent, tangent, no curves. Another one is with the curves. Another one is the curve and spiral settings. So click on the curve and spiral settings, and then it brings a box, and here you can choose a type in which the curves will be calculated. So now this is the method we're going to use it. That's a default method. You can use different methods as well. And then there's a spiral in and spiral out. And we're going to uncheck the spiral in and spiral out because for this one we don't need spirals, so we're just going to uncheck those ones. And then the minimum curve radius, it's 200, so I'm going to keep it as, let's say, 50 meters. So that means it will have shorter curves. Okay, and then I'm going to choose this option, and then I'm going to choose tangent, tangent, no curves, and then I'm going to click, click, click. So that's got the alignment. We got our first alignment, and then there is no curves in it. But remember, as I said, make sure that you close your fly toolbar. What happens is when you come back from your break, and remember, be still at CL1, which is your first alignment, M1 road CL1. So if you keep this open, you come back and then you think that, okay, let me draw my second alignment. And then you think that, okay, it's like a polyline command, and then you keep drawing it. But if you look at it, they both are one single object. It's not like polyline, it's a smart object. So it actually thinks that you're starting from here and then the alignment continues from here. So this would create confusions. All right, so you can do undo here, so which will take you back one step further. So this is actually an inline command undo, so which is a bit more smarter compared to this undo, which undoes the entire edit as one operation. So now that's the first alignment that we have created. Now if you want to create it with the curve, you can choose tangent, tangent with curves, and then let's say this is my ending station. I can select from here, and then I can continue creating with curves. And then if you see, the minimum radius has been applied, so the curves are a bit tighter. So there is a whole bunch of other tools here. So this is just an alignment introduction. So let's get into a bit more alignment in the coming chapters. All right. Thanks, guys. Thanks for watching, and subscribe to the channel. And if you have any specific questions, please ask us and we'll help you out. Thank you.